Good morning, students. Today let us discuss about electric dipole and dipole moment. Okay. As you all know, what is a dipole? Di means two. In the case of electric dipole, this two indicates two different types of charges. That is a positive charge and a negative charge. Now this system consisting of two equal and opposite charges constitute a dipole. Okay. Now from the figure you can see there is a negative charge and a positive charge. They are kept separated by a very small distance. Here I have marked the distance as 2a. This arrangement we call it as an electric dipole. Clear? Now its polarity is explained in terms of dipole moment. Dipole moment. Okay. Now dipole moment is usually represented by the letter P, vector P. Okay. Now this dipole moment is measured as the product of magnitude of one of the charge and the distance of separation between the charges. That means the product of one of the charge, that is Q, and the distance of separation between them, that is 2a. So you will get the equation for dipole moment as 2aq. So this is the expression for electric dipole moment. Okay, it explains the polarity of the dipole. And it is a vector quantity. Its direction is from negative to positive, and it will have an SI unit 2a. 2a is the distance. So what is the unit for distance? Meter. Now what is the distance of charge? Coulomb. So the SI unit of dipole moment is Coulomb meter. Okay, students, now we can discuss about the electric field produced by the dipole. We know that the dipole consists of positive and negative charges. The total charge of the dipole is 0. Then also the dipole will produce electric field around it. Okay. So in the examination point of view, it is very important side of the first chapter. That means we are going to find the electric field along the axis of the dipole as well as along the equatorial line of the dipole. Okay. So the first part is we are going to calculate the electric field along the axial line of the dipole. Electric field along the axial line of the dipole. Now before that, what do you mean by axial line? What do you mean by axis? Axis means the line which is passing through the center of charges. That means this dotted line we are considered as the axial line. And along the axis we have to take a point P which is at a distance r from the center of the dipole, where we have to find the electric field. Okay, that means our aim is to find electric field at the point P which is at a distance r from the center of the dipole. Okay, now let us see how can we calculate the net electric field at P. Now for that, from the figure we can see the negative charge minus Q is at a distance r plus a from the point P. Okay, and the positive charge, the distance between the positive charge and the point P is r minus a. Okay, so you got the distance of separation between the charges from the point P. Now already we have the formula for calculating electric field. What is that formula? It is electric field E equals 1 by 4 pi epsilon 0 Q by r square. Now by using that formula, here we are going to calculate the electric field. Okay. Now for that, the electric field at P due to the charge minus Q, by using the same formula you can write 1 by 4 pi epsilon 0 Q divided by, instead of r square, here the distance is r plus a whole square. Now along PA. Now what is this along PA indicate? PA indicates the direction of electric field. Since the charge is negative, we know that the direction of electric field is inward. Inward means towards negative charge. That means the direction is marked as PA. Clear? Now coming to the second electric field due to the positive charge. Now what is the distance of separation between the positive charge and the point P? The distance of separation is r minus a. Right? This much is r and this is a. So this distance can be taken as r minus a. Now the electric field E plus Q equals 1 by 4 pi epsilon 0 Q divided by, instead of R square, here we have to write R minus A whole square along BP. Now what is BP indicates? The direction BP means the outward direction. So at the point P, just look at the directions of electric field. E plus Q in the outward direction and E minus Q in the inward direction. That means both the fields are in the opposite direction. Now, if the two vectors are in the opposite direction, how will you find the resultant? How can we find the resultant? Just by subtracting the smaller vector from the bigger vector, and you have to give the direction of the bigger vector. So, the same procedure we can do. Okay. Now, from this, tell me which one is greater, E plus Q or E minus Q? Now, from the equation it is clear that the bigger vector is E plus Q. So, you have to subtract E minus Q from E plus Q. So, the resultant electric field E equals E plus Q minus E minus Q, and its direction is along BP because E plus Q is the bigger vector. Okay. Now, we can just give substitution for both E plus Q and E minus Q and take the common term outside. Okay. Now, so that in both the equation, common term is Q by 4 pi epsilon 0. So, Q by 4 pi epsilon 0 can be taken outside. Now, within the bracket, 1 by R minus A whole square minus 1 by R plus A whole square. Now, you have to make the denominators equal by cross multiplying. So, you will get Q by 4 pi epsilon 0 R plus A whole square minus R minus A whole square, and the denominator becomes R plus A into R minus A the whole square. Now, this is of the form, denominator is of the form A plus B into A minus B. This can be written as A square minus B square, that is here R square minus A square the whole square. Now, coming to the numerator side, A plus B whole square minus A minus B whole square. So, by expanding the terms, you will get it is 4AB. Now, here instead of A, here it is R, and instead of B, here it is A. So, you will get 4AR. Clear this much? Okay. Now, here we are doing an approximation, that is, if the distance R is very large compared to that of A. Now, from the figure we can see R is a very large distance compared to A. So, we can neglect A related with R. So, that approximation here we are doing, that approximation, so that E equals Q by 4 pi epsilon 0 4AR divided by, we are neglecting A in the denominator. So, here becomes R square whole square. R square whole square means R raised to 4. Okay. Now, we can cancel R from the numerator and denominator, so that our equation becomes Q by 4 pi epsilon 0 4A divided by R cube. Okay. Now, I am going to split 4A as 2 into 2A, and I am taking Q together with 2A, so that I can introduce dipole moment P instead of 2AQ. So that our equation becomes E equals 1 by 4 pi epsilon 0 2P by R cube, and its direction is along BP. Now, what do you mean by BP? Outward direction. Now, already I explained what is the direction of dipole moment. The direction of dipole moment is from negative to positive. That means the same as that of BP. That means we can say the direction of the net electric field is along the same direction of dipole moment. Clear? Now, we can explain what is the strength of electric field along the equatorial line of the dipole. Okay, already now explained what is the electric field along the axial line. Now, tell me what is equatorial line. Equatorial line means the line which is passing through the center of the dipole, but it should be perpendicular to the length of the dipole. So, here this is the dotted line that represents the equatorial line. Now, along the equatorial line, same as before, here we have to consider a point P at a distance R from the center of the dipole, where we have to find the net electric field. Okay, so this is P is a point at a distance R from the center of the dipole, where we have to find the total field. Okay, now same as before, the distance between P and the negative charge you have to calculate, as well as the distance between P and the positive charge you have to calculate. And we know that the center of the dipole is O, so that the distance OA becomes A and the distance OB becomes A. Okay, and also we know that the distance OP is R. Now by using Pythagoras theorem, by taking the triangle APO, okay, APO, by applying Pythagoras theorem, we can find the distance AP as root of r square plus a square. In the same way, from the triangle OPB, here also we can calculate the distance PB as root of r square plus a square. That means this is an isosceles triangle with both sides are equal. Okay. Now if the sides are equal, we can say that their opposite angles are also equal. So that I can mark both the angles as theta. Clear this much? Now we have to calculate the electric field at P separately produced by the charge negative charge minus Q as well as the positive charge plus Q by using the same equation as above, that is 1 by 4 pi epsilon 0 Q by r square. Now tell me, what is the equation for electric field at P due to this negative charge minus Q? We can write the equation as E minus Q equals 1 by 4 pi epsilon 0 Q by r square. Here instead of r square, the distance is root of r square plus a square. Root of r square plus a square whole square comes, so that it becomes r square plus a square. Now what about its direction? It is a negative charge, so its direction is inward. The direction of electric field is inward. Inward means towards PA. So we can mark the direction along PA. Okay. Now what is the magnitude of the electric field at P due to positive charge? Again, the positive charge is also at the same distance root of r square plus a square, and the strength of the charge is also same. So you will get the same equation, E plus Q equals 1 by 4 pi epsilon 0 Q divided by r square plus a square, and the direction is only different. It is along BP. What is the reason for BP? Because it is a positive charge, so its direction is outward. Okay. So from these two equations we can say that the magnitudes of both the fields are same. E plus Q and E minus Q, their magnitudes are same. Now what about its direction? They are in different direction. Okay. So in order to find the resultant here, we have to do the process of resolution of vectors. Now tell me, what do you mean by resolution? How will you resolve vectors that we have studied in 11th standard? How can we resolve vectors? So here I am going to resolve both the vectors E minus Q and E plus Q. Okay. Now from the figure it is clear that these angles are alternate angles. So if this angle is theta, this angle is also theta. Now by resolving E minus Q, the component of E minus Q along the direction of theta is E minus Q cos theta. And the perpendicular component is E minus Q sin theta. Clear? And also I am going to resolve E plus Q. Again, these angles are corresponding angles. So if this angle is theta, this angle is also theta. Now the components of E plus Q becomes E plus Q cos theta along the direction of theta and E plus Q sin theta in the upward direction. So from the figure we can see there are two components. One is E plus Q sin theta in the upward direction and E minus Q sin theta in the downward direction. Now we can cancel these two components. What is the reason? Because the magnitude of E minus Q and E plus Q are equal. The sign components also will be equal. So we can cancel E minus Q sin theta and E plus Q sin theta. So the net electric field at P is the contribution of cosine components. So what are the two cos components? One is E plus Q cos theta and the other one is E minus Q cos theta, and both are acting towards left. Left means along BA. Right? So the net electric field at P is the resultant of these two. So we can write the net electric field E equals E minus Q cos theta plus E plus Q cos theta. We know that the magnitudes of E minus Q and E plus Q are same. That means these two terms are equal. So we know that x plus x will give you twice x. So by adding these two, you will get twice E plus Q cos theta. Mark this equation as 1, and its direction is, again I am explaining, its direction is towards left. Means along BA. Okay. Now in order to find the resultant from this equation, you have to substitute both for E plus Q and for cos theta. Okay. Now it is mathematical part. Now how will you find cos theta from the figure? We can find cos theta from the figure by taking the triangle APO. What is cos theta? Tell me. How will you find cos theta? It is adjacent side by hypotenuse. So here the adjacent side is a and the hypotenuse is root of r square plus a square. So we can write cos theta equals a divided by root of r square plus a square from the triangle APO. Okay. Now already we know E plus Q is 1 by 4 pi epsilon 0 Q divided by r square plus a square. So I'm going to substitute both for cos theta and for E plus Q. So that you will get E is equal to twice into 1 by 4 pi epsilon 0 Q divided by r square plus a square. This is E plus Q and this is for cos theta, a divided by root of r square plus a square. Now look at the denominator. There comes r square plus a square and root of r square plus a square. Now what about their powers? Its power is 1 and its power is half. So 1 plus half will give you 3 by 2. So that the denominator becomes r square plus a square whole raised to 3 by 2. And in the numerator there comes 2aq. What is our 2aq? 2aq is the dipole moment. Okay. So instead of 2aq you can give p. That is the dipole moment. Now we can do the same approximation as before. That is, if r is far greater than a, then we can neglect a. So if we are neglecting a, our denominator becomes r square whole raised to 3 by 2. R square whole raised to 3 by 2 means r cube. So that our final equation for electric field along the equatorial line of the dipole is 1 by 4 pi epsilon 0 P by r cube. Now tell me what about its direction? The net electric field is towards left. That is from B to A. That is it in the same direction of dipole moment or in the opposite direction of dipole moment? It is in the opposite direction of dipole moment. Do you understand about the axial line as well as equatorial line of dipole, how we are calculating the electric field? It's very important side. Okay, you have to study it. That's all. I'm going to wind up the class today. Thank you.